Lesson N7-5, exponential equations. An exponential equation will have a term of the form a to the x power. In other words, it will have a variable in the exponent. So one way we can solve exponential equations is that they can sometimes be solved using the laws of exponents and the following property, which is a result of the exponential function being one-to-one. One of the characteristics we've looked at of exponential functions is that they are one-to-one. Because of that, if we have an exponential equation b to the m power equals b to the n power where the bases are the same here, then it has to be true that the exponents are equal. M is equal to n. So we're going to use that to be solving equations in this part of the unit. Once we get to the logarithms, we'll see other ways we can solve exponential equations. But for right now, this will pretty much be it. This is the way we will solve exponential equations. So, slide this up a little bit and let's see what we can do with this. So number one, 2 to the third power times 2 to the x power equals 16 to the negative x. So we're going to use all of those properties that we learned back, the laws of exponents from the first lesson. I know when I multiply with the same base, I add the exponents. So I can write this as 2 to the 3 plus x power. And I want the same base on both sides, and I know 16 is also a power of 2. It is 2 to the 4th power. And I'm raising that to the negative x. And when we raise a power to a power, we multiply. So I've got 2 to the 3 plus x equals 2 to the negative 4x when I multiply negative x times 4. And now since the bases are the same, we can equate the exponents. 3 plus x equals negative 4x. Let's get our x's on the same side, subtract x from both sides. And I get 3 equals negative 5x. Divide both sides by negative 5. And x equals negative 3/5. X equals negative 3/5 here. Number 2. 8 to the x squared power over 4 to the x power equals 2. 2, 4, and 8 are my bases. All of them are powers of 2. So I'm going to leave 2 alone. But 8, I'm going to change that to 2 to the third power. So I have 2 to the third power raised to the x squared power. 4 is 2 squared. So 2 squared raised to the x power equals 2. Raising a power to a power, I multiply. So this is going to be 2 to the 3x squared divided by 2 to the 2x equals 2. When I divide with the same base, I subtract. So I can write this as 2 to the 3x squared minus 2x power equals 2. And there's an understood 1 here. So now that I've got the bases the same, I can equate the exponents. I'm going to come over here to do that. 3x squared minus 2x equals 1. I've got a quadratic, so I'm going to subtract the 1 to get it equal to 0. 3x squared minus 2x minus 1 equals 0. Multiplying 3 times negative 1 gives me negative 3. So I need two numbers that multiply to give me negative 3, that add to give me negative 2. And that's going to be a negative 3 and a positive 1. So 3x squared minus 3x plus 1x minus 1 equals 0. So notice this negative 2x got split up between the negative 3x and the positive 1x. Now I'm looking for, I'm going to factor by grouping. The first two, they have in common a 3x. And I'm left with x minus 1. And here I have nothing in common, so I'm going to factor out a 1 times x minus 1. So 3x plus 1 times x minus 1 equals 0. 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1/3. Or x minus 1 equals 0. X equals positive 1. It's kind of a long one there. Alright, number 3. 3 to the x power equals 1 over 27. 3 and 27 are both powers of 3, so 3 I can leave alone. I can call this 3 to the x power. 1 over 27 is like 1 over 3 to the third. I can write that as 3 to the negative 3. So x equals negative 3. I'm just equating the exponents. X equals negative 3. Number 4, once again, powers of 3 here. So 9 is 3 squared. Let me center this a little bit. 9 is 3 squared. So 3 squared to the x plus 1. 27 is 3 to the third. And I'm taking the square root, which is like the 1/2 power. So distributing, I'm doing 2 times x plus 1, raising a power to a power. I multiply. So I'm going to distribute here. 2x plus 2. And here I'm raising power to a power, so I multiply. 3 times 1/2 is 3 halves. So now equating my exponents, 2x plus 2 equals 3 halves. Subtracting 2 from both sides, 2 would be 4 halves. So this is negative 1/2 equals 2x. Dividing both sides by 2 or multiplying times 1/2 gives me x equals negative 1/4. All right, number 5. Both sides I have powers of 5. 1/5 is 5 to the negative 1 power. And I'm raising that to the 2 minus x. 25 is 5 to the second power. Raising a power to a power, I'm going to multiply negative 1, so I've got to distribute it here. We'll have 5 to the negative 2, and negative 1 times the negative x is going to be plus x equals 5 squared. My bases are the same. I equate the exponents. And 2 plus x equals 2. I'm going to add 2 to both sides, and I get x equals 4. This is a little bit number 6. I've got 4 to the x power minus 2 to the x power equals 0. Well, I want base with an exponent equals base with an exponent. So I'm going to add the 2x to the other side, 2 to the x power, right off the bat. 4 to the x equals 2 to the x power. Now I'm going to put them both as base 2. So 4 is 2 squared to the x equals 2 to the x. Raising power to a power, I multiply 2 to the 2x equals 2 to the x. My bases are the same. I'm going to equate the exponents. 2x equals x. And then I'm going to subtract x from both sides. Subtracting 1x gives me x equals 0. The only thing that will work there, x equals 0. Last problem. E to the x squared equals e to the x squared. All right, so raising a power to a power, I multiply my exponents. So x times 2, that's e to the 2x equals e to the x squared. Now I'm going to equate my exponents. 2x equals x squared. It's a quadratic. I'm going to subtract the 2x over to the right. X squared minus 2x. This time factoring, I've got a common factor of x. So I'm going to factor out an x. That will leave me x minus 2. And now I split it apart using my zero product property. X equals 0. That's one solution. X minus 2 equals 0 gives me x equals 2. So two solutions there, 0 or 2. We are done.